Imagine standing on seemingly solid ground, feeling a sudden jolt. The sensation is unlike anything you've ever felt before. It's as if the very foundation of your world is being pulled out from under you. The earth beneath your feet begins to tremble. A gentle vibration at first. You might notice small objects around you starting to shake, a subtle hint of the chaos that's about to unfold. Then the tremors intensify, transforming from a hum into a roar. The sound is deafening, a cacophony of nature's raw power. You can see the ripples in water, each wave a testament to the energy being released. Buildings sway, windows rattle, and the ground undulates like waves on the ocean. The skyline, once a symbol of human achievement, now appears fragile and vulnerable. This is the raw power of an earthquake, a stark reminder of nature's immense force. The landscape is transformed in an instant, leaving behind a trail of destruction. Earthquakes are more than just fleeting moments of ground shaking. They are powerful geological events that can reshape landscapes and leave lasting impacts on human civilization. The aftermath is a sobering sight, with cracked ground and damaged buildings as far as the eye can see. The Earth's crust, far from being a static and unyielding shell, is a dynamic system made up of massive tectonic plates in constant, albeit slow, motion. These plates are the puzzle pieces of our planet, fitting together in a complex and ever-changing mosaic. These plates grind against each other, building up immense pressure over time. This pressure is like a ticking time bomb, waiting for the right moment to release its energy. When this pressure exceeds the strength of the rocks, it releases with a sudden jolt, sending shockwaves through the earth. These shockwaves travel vast distances, shaking everything in their path. The experience of an earthquake is both terrifying and humbling. People react with a mix of fear and awe, witnessing firsthand the incredible power of our planet. It is a stark reminder of our planet's immense power and the forces that have shaped it over millions of years. The landscape, forever altered, tells the story of these powerful forces at work. Understanding these forces, their causes, and their potential consequences is crucial for us to coexist with our dynamic planet. By studying earthquakes, we gain insights into the inner workings of the Earth, helping us to better prepare for and mitigate the impacts of these natural events. The Earth's crust, the outermost layer of our planet, is not a single solid piece. Instead, it is a complex and dynamic structure that plays a crucial role in the geological activity we observe on the surface. It is broken into numerous fragments known as tectonic plates, which fit together like a giant jigsaw puzzle. These plates are constantly interacting with one another, creating a dynamic and ever-changing landscape. These plates are in constant motion, driven by the heat emanating from the Earth's core. This heat is a result of radioactive decay and residual heat from the planet's formation, which generates immense energy. This heat creates convection currents in the mantle, the layer beneath the crust, causing the plates to move, albeit very slowly, at rates of a few centimeters per year. These convection currents are similar to the way water boils in a pot, with hot material rising and cooler material sinking. Most earthquakes occur along the boundaries of these tectonic plates. These boundaries are zones of intense geological activity where plates interact in various ways, such as colliding, sliding past each other, or pulling apart. As the plates move past, push against, or pull apart from each other, immense pressure builds up along their edges. This pressure accumulates over time, creating significant stress within the rocks at these boundaries. This pressure is stored in the rocks as potential energy. The rocks can only withstand so much stress before they reach their breaking point. When the stress exceeds the strength of the rocks, they rupture, releasing the pent-up energy in the form of seismic waves. This sudden release of energy is what we experience as an earthquake. These seismic waves are vibrations that travel through the Earth's crust and are responsible for the shaking we feel during an earthquake. The intensity and duration of the shaking depend on the amount of energy released and the distance from the epicenter. So there are different types of seismic waves, each with its own characteristics and propagation patterns. Primary waves, or P waves, are the fastest and travel through both solid and liquid layers of the Earth. Secondary waves, or S waves, are slower and can only move through solid materials. The study of these waves, known as seismology, helps scientists understand the mechanics of earthquakes and their impacts. By analyzing seismograph data, researchers can determine the location, depth, and magnitude of an earthquake, providing valuable information for disaster preparedness and mitigation.